Hi everyone, and welcome to another almost daily TidalCycles video. So this time we're going to continue from where we left off with trying to code some randomness when it comes to chords. We had talked about the 11th chord and, you know, and the ways in which with 11th chords, like for example the dominant 11th and such, you you often remove some notes from the chord because the 11th chord has a total of 6 notes in it, right? And so that's a lot. Like it can be very crunchy and dense easily. So instead, you want to sometimes you want to take parts of that out, and there's different musical reasons for why you would do that. Now, the important point here is that we don't like to just do things, planned. We want elements of randomness and surprise. So how do we make some functions so that we're actually dropping a random element of the 11th? Okay. And that's why we want to talk about. So we did this last time. It's just a little bit of a reminder that we did this thing of, okay, what's chord scale? We map a scale onto the degrees of a list. Like we take a list of numbers and treat those as integers. They're the degrees, the scale degrees. We map the scale onto it. We we use the map here to make sure that the tonic note shifts this around correctly. We and then we so we in this case, like, we're doing the dominant, so we actually like flatten one of them. But then the question is, so the point at which we do the stack is the point at which we flatten the whole thing. So between there, what we want is some function to put that will, between the stack and the flatten 3, that will take the that will actually take this list here and then randomly remove something out of it. Okay. So let's talk about how to just remove something out of the middle of a list. Okay. So the way we would do that is, I don't know. Sometimes I find Adam will suggest autocomplete things where I'm just like, what is that? What even is that? And sorry, I had a bit of a coughing thing there for a moment. Okay, so we want to say we want to remove. Let's call it like rem list or rem inf. In val. And so what is this going to be? Well, this is basically the same as our split function, right? Except instead of having the focus in the middle, we're going to say take name of val plus plus. And the plus plus, if you don't remember off the top of your head, signifies that it's it basically signifies that it's it's concatenation of lists. Okay, so let's just, okay, yes, that does in fact load. Great. Okay, and let's just make sure that it does the right thing. So let's say 2, 4, 6, 8, 10. Okay, what does this do? Well, it does that, which is exactly what we want. It removes the so again, we're doing 0 indexing, so rem in for 3 will be the 3rd, which is the 4th if you're starting from 1 as opposed to counting the 0th. Okay. Now this isn't the safest function in the world because, like, let's just check here. If I say rem in for 10, okay, it does in fact take everything. If I were to say if I say -1, okay, it does. Okay, so I think this is actually safer than I thought. It does seem to not get super funky. Meanwhile, I think split is less. Yeah, because I'm actually trying to access the element. Split doesn't behave as nicely. It sort of can't. I mean, I suppose you could do a thing where I could write a guard so that it, if the number was larger or smaller, smaller than 0 or larger than the length of the list, we could just return. Since it is supposed to split them, the problem is that you would have to have a maybe type and a nothing there, because there just isn't a well-defined answer. But anyway, slight Haskell programming philosophy digressions. But yes, okay. So we do this. Okay, fine, great, good. Of course, and so this would allow us to do a thing like rem inf of, say, the 9th of the chord. Okay. If we did something like that, then we'd be able to hear. So let's say super piano, and then is going to be the 11th of let's just say major, and then let's just let the tonic. Let's just let it be. Let's just let it be C. Okay, and then fixing my typo before I mess something up. And let's say sustain 0, 2. Okay. All right. So let's just listen to this. And what did I do wrong? Pattern control map. I am slightly confused here. Let's think about this for a second. What have I actually written? Because stack pattern, okay, Ah, okay. So weirdly, I think there's some coercions happening. Because I think I actually need to do that. Okay, and then the types are properly general. Okay, and then this should work. Yeah, that's pretty crunchy. We can also just double check here what it's giving us. And so I think that's right. It's giving us the yes, that's correct. And also, man, though, why is the? It feels almost like the sustain isn't doing anything. No, it is. Here, let's just slow this down. Oh my goodness. Okay. Sorry, I was doing something earlier, that involved changing the cycles per second. So that's part of the reason why it felt like weirdly fast. Okay, so it's 35 over 240. I'm gonna slow it down. Let's just do a little low pass filter for fun. Let's also actually drop this an octave. Still slightly confused about why it sounds so. Because, like, normally I would expect, you know, if we do something silly like this, right? And then Rand 10 scale major. I don't know. Sorry, I'm distracting myself by trying to make the super piano sound better because it's sounding kind of off to me right now. Here, I'm just partly turning up the gain on my own computer just to see if maybe it being a little quiet is part of why it sounds weird. to me. Anyway, let's try this again. And so we want, so this is, and then if we were to change other things, we could do like, yeah, so you can hear that as we change this, we are in fact changing which notes removed. Here we can remove the top, which, you know, defeats the purpose of the keynote 11th, but that's fine. So the point here is that we then want to take this remove inv, and we want to make it take a pattern. So I think honestly the correct way to do that is to maybe just do something really simple like is, in fact, I'm going to look at some other code of mine just for some slight inspiration. Because, yeah, I think all I want is to just do a fmap. Yeah, that's what I want to do. Okay. There's also, I swear there's a thing that lets you lift things up to being patterns, but in the code base. But this should work fine. So that's actually, yeah, maybe I actually should flip the order of the arguments, but we'll, no, I actually like it this way. Okay. What do you mean infinite type? Oh my goodness. Okay, there. And what's the type of element P? It is. So give us this super general type, but that's fine. Functor f int. Okay, so that should be good, because if we just say pattern event, then it should give us a pattern of lists. As we say in Texas, yeehaw. Now, what we want from here is, so what we should be able to do is something like this. Say iram 5. Is that I'll take a list patterns, turn a okay, wait though. interesting. This won't work. And let me tell you why it won't work. Because stack doesn't take a pattern of a list of parents, it takes a list of patterns. Okay? Now, what we could do is could fmap stack. If we fmap stack, then it should do the right thing. Now, okay, so at this point though, we'd have to do something like this. By join, yeah. What's the join called in, yeah. It's not called that, it's called, unwrap? Is that that's the join. Yeah, unwrap is that's the join of patterns. So yeah, if we do that, I think that works. Let's try it. Okay. Compiles. Let's now, aha. Now the problem is that we're going to actually have to flip the order here. We can't have that D11th be the sort of, no pun intended, dominant part. Because otherwise we would have to put a segment on it in order for it to be properly discretized in a way that can, Tidal can do something about. But we can put it here in this like modifier position, not as the structure of the pattern. Okay, so let's see what happens, because now we should get a different note removed per event. Okay. Let's slow it down even more. Let's okay, you can definitely hear that it's removing different notes, which is great. That's really all we wanted. I feel like I'll almost like move this down just a little, just a skosh. It's a little harder to tell that they're different. Okay, so it's definitely different. So cool. I'm not entirely sure what I'm doing with this yet, and not entirely convinced I haven't made a bunch of mistakes from a music theory perspective. But at the very least, we are clearly removing the right, like a note at a time. And if we want to make it multiple notes, should be able to do something silly like this. Let's, yeah. Let me see. I'm trying to remember actually, does Iran, I think it's okay if I do this. Then I could say 5 here. And then... What? What? What are you cranky about? What did I do? I'm very confused. Oh, why can't I do that more than once? What? Oh, foolishness. That's right, okay. I'm getting lost in the weeds on creating patterns and patterns and patterns. So yeah, actually let's, which makes sense. Can stack multiple unwraps here, I think, and then do rem inf p iran fmap. Okay. Oh, would you stop horsing around? Let's look at our types. Oh. There. Okay, that was just an association problem. Okay, so now let's hear this, because it's probably going to be a little... Should be removing 2 notes each time. Yeah, okay, so that's clearly working. And that's kind of neat. I don't know, that's kind of fun. I have no idea what I'm going to use this for, but it seemed like an interesting application of building up patterns and such. Maybe it'll inspire someone else, I don't know. But, so yeah, that's today's video, and tomorrow I should be doing a version of cleaning up code from the Spindrift performance, and then maybe trying to expand on it a little, and then do like a longer version of the performance rather than like the like just tight 5-minute thing that I feel, you know, didn't entirely have room to breathe. But it was also like a proof of concept that was honestly pretty cool. Anyway, so until tomorrow, take care.